convention. Notice the white matter's down here, and so layer 6 is right on top of the white matter. Layer 1 is at the tippy-toppy part, on the outside of the cortex. That was a science term, tippy-toppy part, the outermost thing. And so the first thing we discovered was 1, 2, 3, 4, 5, and 6. He's hand drawing it, yeah.
Just going back a little bit, how do the pyramidal neurons and stellate ones, how do they work together?
In a second, I'm going to go through the steps, and I think it will help or make it much worse. Let's see how it goes.
Or the latter.
As we got better at examining these structures, we realized that layer 4 was divided into 3 sublayers: 4A, 4B, and 4C. And then as we got really a lot better, we realized that 4C was divided into 2 new areas, 4C alpha and 4C beta. Everything about visual processing, incoming visual stimuli, is about 4C alpha and 4C beta. Making, what?
Can you repeat that?
Yeah, everything about incoming visual processing here, of incoming visual stimuli, is about 4C alpha and 4C beta.
Thank you.
Making this the most awkward naming convention of all time. So that's these guys right here. And as you can see, like a lot of things, it happened because of history. We didn't want to change every journal article in the past, and so to help people be able to map what was in the past to now, we kind of did this bridge. Yeah, Catherine?
So does it move up from layer 6, 5, and then gets to 4C alpha and 4C beta, and it's processed, or why are those 2 layers so important if they're like in the middle of the layering?
All the incoming visual information bypasses these
Okay.
and goes right into 4C and alpha and beta. And we're going to talk about why that is. Because remember, this piece of cortex is doing more than one thing.
So
Yes.
what goes through 6 and 5?
Ooh, good question. You know those resting attentional networks? They're all about 6 and 5. They're all about 6 and 5. And so, good question. So when we're talking resting, we're talking 6 and 5. But here, we're talking about what comes in versus what goes out. And so 4C alpha and beta is what comes in. It actually leaves through 3. The visual information actually leaves through 3. And I'll show you the model. Yeah.
So are 4C alpha and 4C beta, are those in the primary visual cortex?
They sure are.
But then when we start getting into 5 and 6, we're getting into the thalamus?
No. This is all the cortex.
Okay.
All the cortex. These are all, right now we're talking about everything coming in from the thalamus. LGN, 4C alpha and 4C beta, are resting potentials like from the pulvinar, like in the reticular nucleus, the intermedullary nuclei. Those are coming in and they're going to be processed in 5 and 6.
So I know a sad revelation.
What?
Got to that question about the pulvinar and the test, what its function. I didn't know what it did.
I know. Yeah, I know. I heard that.
I felt really bad.
Why? It's hard, and it's a very large structure, and so it's not immediately obvious.
I feel like I let you down.
So not true. All right. Here is a diagram now of the same thing, but we're going to look at input and output streams, and I'm going to do it one at a time. And so we have step 1, 2, 3A, and 3B. And we're not going to cover 3B too much. But here we go. This is incoming visual information. All right. Here we have our stellate cells. Hey, could you shut the doors for me, guys? Her voice just became alerting enough to make me want to go smack her, so.
I feel like after we learned that attention, it just kind of
It did. So this is step one, right from the LGN into this layer with those very spiny cells here. And so it starts here.
That's layer 4.
Yep. Alpha and 4C alpha and 4C beta. And actually one receives information from the parvo and one receives information from the magno. That's why they're two different layers. But do we care? No, not right now, because I'm also not going to talk about the conocellular layer. Yes.
Magnocellular and parvocellular, do those only refer to the visual cortex?
Yes.
They're not like other parts of those streams?
Well, what happens when we divide out in the stream after this part of the cortex? Where does the parvocellular information go? Which stream? Dorsal or ventral?
Ventral.
Or what?
Ventral, because parvo is fine detail, the what pathway, right? You guys got it, you got it. And so what happens is after this moment, it then divides out on its streams. And so as it leaves, so when we leave here, they're gonna start on their journeys on their different streams. So that is an amazing question. But from here, from the LGN to here, they're actually in their layers with two other layers of cell. Bless you. Bless you. That we don't know what they do. Yes.
What's the other structure you said that receives information from? It was the LGN and
Yeah, well, we're going to talk about the LGN, the lateral geniculate nucleus, which processes visual information. So this is our basal nuclei. And then we're also going to talk about resting information. At the same time that this information is coming in here for the resting information, we have other information coming in that's just our ongoing oscillation from the thalamus through the reticular nucleus. And that's coming into layer 3. In step 2, these neurons pass information to the dendrites of pyramidal cells in 4B and 3. Basically, here are our pyramidal cells. See how they are junctures? They have little buds all the way up them, and these stellate neurons are passing information. So if 4C is receiving that visual information from the external world, and 3 is receiving our ongoing arousal at any moment in time from the thalamus, by the time this dendrite gets to here, it's got both types of information in there. By the time it gets to here, it's got both types of information. Yes.
What does 3 receive?
It gets the ongoing, like from the reticular nucleus, it's the resting part of that loop, the resting state part of that loop. I said resting state, I'm going to use that word, but you know, our resting attention, our sustained attention, our relaxed attention. Yes.
Are the pyramidal cells the same as the Betz cells we talked about way earlier in this semester?
Yes. Exactly the same.
Okay.
Yes.
So if we get something like,
A
if
good
we
question.
see something like flash, does that override the stuff we're receiving on layer 3 and become more focused?
Exactly.
Okay.
This is that place where those two things, she's asking if something interrupts, what happens? Well, remember the reticular nucleus, first of all, is going to go, whoa!
Mm-hmm.
And so it's going to send a signal, and that signal is going to amplify what's being received.
Okay. So it would receive more of the things on layer 4 than it would from layer 3?
Yeah, well, yes.
Okay.
But the weird thing is remember that the LGN passes through the reticular nucleus, changing the activity of the reticular nucleus, changing what came in on layer 3 too. So it's 2 places it changed the loop. Remember all those awful deceptive pluses and minuses in this? Remember these guys way back? Look at this. There is a plus here that can affect things going up, and also pluses here that can affect things going up. And then deadly enough in the reticular nucleus,